So I will start. So in this presentation, I will start from the basic language features of Scala, and then explain more features related to two totally different programming paradigm: object-oriented programming and functional programming, shortly OP and FP. And then I will introduce several collection libraries already defined in Scala. And finally, I will describe Homer's framework and how to explain how to use it and how to submit it into Scala. So also if you have any questions during this presentation, just interrupt me and ask any questions. So what is Scala? So the name Scala stands for scalable language. So because it was designed, at the first time it was designed for concise style to reduce program size. So compared with Java, the Scala program has a small size and they have concise style code. And also you can apply Scala into a wide range of programming tasks, from writing small scripts to building large systems. And also Scala is interoperable with Java. It means that Scala programs will be compiled into JVM bytecodes and then run on JVM, Java Virtual Machine. So you can, after compiling Scala programs, you can run them anywhere with JVM, Java Virtual Machine. And also, one of the strongest points of Scala is that it supports both the object-oriented and functional style. So I will explain both of them later in this presentation. And also Scala supports not only compiler but also interpreter. It means that you can run a Scala program line by line. So also Scala supports REPL style interpreter. It means REPL means read, eval, print, read. So it means that the Scala interpreter reads an expression and evaluates it, and then prints the result and repeat again and again. So if you want to start Scala interpreter, just type Scala command on the shell, then you can look this display. And from now, I will explain basic language features using this interpreter. So let's start from primitive values. So in Scala, there are 8 different primitive types, but in this class, we will use only 3 of them: integer, string, and boolean. And also you can use various primitive operators. You can add 2 integers or repeat strings or boolean logical operator like that. And Scala supports immutable variables using the keyword val. So you can define immutable variable, integer type immutable variable x with an initial value 1. Then the value 1 will be stored in the variable x. And you can use it like this. So x plus 1 is equal to 1 plus 1, so it will be evaluated to 2. And also you can define an immutable variable without explicit type like this. Then the interpreter or compiler automatically infer its type based on initial value. So in this case, initial value is string value. So its y's type automatically will be determined as string. So, and I said that this variable is immutable. It means that you cannot change the value. So after you initialize, you cannot change the value inside the immutable variable. So if you try to change the value like that, then interpreter says it is an error because you try to reassign to immutable variable. And also you should match correct type between variable type and value type, initial value type. So in this example, the variable str has string type, but initial value has integer type. So it throws on time mismatch error. But Scala supports not only immutable variable, but also mutable variable with the keyword var. So if you define mutable variable x like that, then you can reassign the another value for it to variable x, and you can use it like that. But in this course, you don't allow to use the mutable variables, and do not use mutable variables in homework because we believe that because mutable variables conflict with functional style, and I will explain it. And we believe that only using immutable variables are really helpful and understandable in this course. And also, you can define functional with the keyword that, like that. Then in this line means you define function named with f, and two parameters x and y with integer parameter, and it returns integer parameter, and each body is this. So it defines addition between two integers. So, and also you can call this function using rounded brackets. Then it means that the value 1 will be passed into x, the value 2 will be passed into y, and the result is x plus y means 1 plus 2, so it is 3. And you should pass correct arguments, correct the number of arguments, and correct the type of arguments. So in this case, it's the wrong number of arguments because this function is 2 parameters, but it passes only 1. And in this case, the second argument is string, but this function is integer argument for second argument. And also Scala supports conditional statements, if then else statements. So actually it's not statement because it is expression, because it returns some value. So in C or like that kind of imperative style, if then else it does not return anything, but in Scala it is also expression, so it returns something. So this is condition part in then body and else body. So if condition is true, then evaluate then body and return, and it is otherwise evaluate else body and return it. So you can define absolute function like that, and so absolute minus 3 is 3 and 42 is 42. So far we learned about basic language features of Scala. Now let's look at the OP style. So what is OP? I believe that you already know OP. And again, but I briefly remind you, OP is a programming paradigm based on the concept of objects, and they have data in terms of fields and codes in terms of methods. So in OP, there are classes and objects, and classes are kind of frame, and it has methods and structures of data, and then you can generate the actual data called object by calling the constructor of classes. So also Scala supports classes, especially case classes. So using case class keyword, you can define case class large A, and this part denotes the field. So this means field K has the type integer. So with this line, you define type large A, and you define constructor name A. So you can call constructor using small rounded brackets like that. So you can create an object with type A like that. So this is calling constructor of the case class A, and number 10 will be assigned into the field K. Then it will be stored in this A object. And then you can access this field using documentation like that. So A.K returns 10 because the object A stores the number 10 into the field K. So this is all this style. And actually Scala supports a normal class similar with Java, but we are focusing on only case classes in this course because case class supports more helper functions, and yeah, so and it is more is more fit into the pattern matching. So I recommend you use always case class instead of class in this course. And also you can define an object without classes. Case object creates an object named B, like that. So in this case, this object B does not relate to any classes in Scala. So in Scala, there are two ways to generate object, using case classes and generate object, or directly create an object using case object. And you can combine the multiple case classes and case object using trait. So actually, trait define a new type named shape, and then you can extend this type with case classes or case object. So in this example, the type shape extends to triangle, rectangle, scale, case class, and shape extends to dot object. So the object dot has the type shape, and all the objects created by triangle or rectangle or scale constructors has their own type and also has type shape also. So for example, you can construct. Okay.
Why do we need the keyword case? Why can't we just declare class rule by saying class or something? Why do we always have to say case plus case object?
Okay. So there are many differences between just classes and case classes. If you just use the class, not case class, then you should write the keyword val here, val A, val B, and val C to use it as the field. And also, it does not just class, not case class, just class does not support default the equality check. So default equality is just in case classes, if you have case class gives us default equality function that check deeply check all the components between objects. But if you use just classes, you should define the equality between in that classes. So there are a lot of differences between case classes and classes, but case class is a more concise style in Scala. So his question is, when we want to define no parameter in class, so assume that there is no parameter in here, then can we use just class? No, no, it is not, because equality function is not only differences between cases, classes, and classes. So yeah, actually, in that case, you can use classes in Scala, but so 한국말로 먼저 답변을 드리자면, 그래서 클래스를 그때는 사용을 하셔도 되긴 해요. 파라미터 없는 거에 대해서 할 때는 사실 근데 파라미터가 없을 때는 그냥 오브젝트를 해도 되고요. 왜냐하면 구분하는 게 없으니까 그냥 오브젝트를 해도 되고, 구분을 하고자 할 때 여기 파라미터 없이 그냥 클래스를 해도 되는데, 또 차이점은 U를 통해서 항상 선정을 해야 돼요. 그래서 여기 같은 그냥 함수 주했는데 U라는 키워드를 붙인다던가 아니면 이런 그 자바 스타일로 회귀를 하게 되거든요. 그러니까 스칼라로 오면서 훨씬 간단해진 신텍스들을 다 사용할 수 있게 만들어놨는데 기본 자바의 클래스를 사용하는 느낌이어서 자바 스타일대로 코딩을 다 좀 블로우업 되게 해야 돼요. 뭐 U를 붙인다던가 별을 붙인다던가 컨스트럭터를 따로 정의한다던가 디폴트로 정의해둔 게 많은데 그걸 다 없애고 그걸 클래스를 사용하게 되면 저희가 다 직접 정의해야 되거든요. 근데 디폴트로 제공해준 게 많기 때문에 케이스 클래스를 쓰면 그런 걸 생각하지 않고도 할 수 있게. Yeah, so in summary, there are a lot of hyper functions in case classes, so I recommend you to use case classes in this course. So we define shape type, a new type shape, and you can create a square object like that, and also it has not only square type but also shape type. You can assign like that. Then the variable shape1 has shape type, and shape2 also has shape type, and has the dot object, the case object dot. But you cannot access the side field of shape1, but it is weird. Someone thinks it is weird because we have square, and square has the field side, but we cannot access side because shape. So we only know the type of variable, so we don't know the actual inside. So shape1 has shape type, so it might be triangle, rectangle, shape, square, or dot. So we don't know it is exactly square type. So it is not allowed in Scala because it's static type. So the variable has the type. And how can access the side field of shape1? You can use pattern matching. So this pattern matching for integer. Pattern matching splits the cases based on this case expressions. So let's look at this example. This is the parameter n with type integer. It matches the cases. If it is equal, n is equal to 42, then return 2. And n is equal to 1 or 2 or 3, then return false. So in pattern matching, it checks line by line, it first, second, third, and fourth. So it matches, the first matches are selective. So actually, and also you can insert the if condition like that. So this means give a name k. So in this input has name n, but in this pattern matching, we will give you another name k, and then if this value k is greater than 43, then we return false. So it means that. So, and this is wildcard, underscore is wildcard. It means that. So again, shape1 is the immutable variable, and it has the type shape, not square, right? And the shape type might be triangle, rectangle, or square or dot. So we don't know it is exactly square or not. So we cannot access side field in here. Extended type. So, and this is a wildcard. It means that we will not give any name into this value. So in this case, we will give you another name k, and this means we will ignore this value. We will not give any name in here. So we can access the field like that. And also, if you use classes, you cannot use pattern matching like that. You should define unapplied function like that. So I will recommend you to define case classes. And in this case, sh variable parameter has shape type, and you can match this type. Then you can split the case triangle, rectangle, square, and dot. Then if sh has the triangle type object, then we can access the field ABC here. And if it has the type rectangle, then we can access WH. So it is matched with the field ABC and with height and side. So we can access this side field of scale like that. So in this case, shape 1 has scale 2. If passing the scale 2 into this parameter, then it goes this case. Then the side field value will be stored in the new variable, immutable variable s, and we can use the field value s like that. And so in this example, triangle 2, 3, 4 will be passed into parameter, then it goes into this case, and 2, 3, 4 we will assign to ABC, so it will return 9. So this is about OOP style. So let's look at the functional programming. Then what is functional programming? In computer science, functional programming is a programming paradigm that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. So in other words, a functional programming, we treat functions as values. In C or the kinds of imperative style programming, functions is not value. Function is just the code. But in this functional programming, functions are could be values. And so mathematical functions is not it is pure. They are pure. It means that always give same result when we put the same argument. But the state is changed. The state is changing. That we can use mutable data. Then it does not give same result, even though we put the same argument. And so I mentioned that functions are values. We can define function value like that. So this is another way. It is another way to define function in functional programming style in Scala. So this is parameter part. There is no name in this syntax. So this is parameter name x and type parameter type is an int, and it returns function body x plus 1. So it defines the increment function without name. So it is just value. So if you type this statement, this expression into interpreter, then it returns the function type, and it will assign it to res 0. So we can store this function value into the immutable variable. So this is the function type int to int. So with this arrow, so we call it as arrow type. So this is parameter type and return type. So there is a function type. So this immutable variable f has function type from integer to integer, and it stores the res 0. If res 0 is this expression. So this expression means the function value. So you can call this like that, even though f is just immutable variable, but this immutable variable f contains the function value. Then function value, with function value we can call it passing the argument 1. Then this 1 will be passed into the variable x and return x plus 1, so it means the 1 plus 1, so it returns 2. So this is the functional programming style coding in Scala. Okay, so, and go deeper. So you can define function 2f. f means our function takes two parameters, f and n. The first parameter has function type. So you can get function type parameter. So first parameter f has integer to integer type, and second parameter n is integer. Then the function body of do f is just call the f with argument n. So do f, call do f with two arguments, this function and number 10. So this function value is first argument, and number 10 is second argument. So first argument is function value that takes one parameter with integer type and returns x multiplied 2, so it's double function. So we pass this double function as first argument and second argument is 10. Then it automatically, this function value is assigned into f here, and 10 will be assigned to n. Then n is 10, f is double function. So we call it, so this number 10 will be came here. So x multiplied 2 is 20. So his question is, what is the difference between function and arrow type? So function has arrow type. So function itself is value in Scala. So the value has always type. So the function value has arrow type. And also there's much simpler syntax. So we don't have to define explicit type of parameter of function value like that, because we use multiply to, and also the first argument has integer to integer type. So we know that the first argument has integer to integer type. And so x is integer type, so we can automatically infer that information. So we do not have to write explicit type of this function value parameter. And also we can write much simpler, like that. This is, we call it as placeholder, because this syntax same as this syntax. So this placeholder means takes one parameter and put that parameter here. So this just one line, one underscore means get one parameter and put that parameter here. So get one parameter, then put the parameter here. So this is same syntax in Scala. So we can define the double function, just like underscore multiply 2 is the function value, that means double function. And also you can define recursive function. So this, we can call it as functional loops. So we can define summation function like that. So if n is greater than 0, n plus summation of n minus 1, then it's definition of summation. So if we push the argument 10 into n, then n is greater than 0, then 10 plus summation 9. So 10 plus summation 9 is also 10 plus 9 plus 8 plus 7 plus over, and if until n is 0, then it is just 0. So it calculates 10 plus 9 plus 2 plus 0. So it returns 45. So it is loops in functional programming style. But in Scala, we also support while and for loops, imperative style loops. So we can also define summation function using while loop. But I think it is much big, much not concise. So also we will use functional programming style code in this course. So in this course, we will not use while or for loops. We will recommend you to use functional style loops, so recursive function, instead of while or for loops. So do not use this while or for loops in homework in this course. So the last one of Scala is we will introduce several collection libraries. Collection libraries is kind of simple data structures frequently used in coding. So I will explain list, option, map, and set. List is list of elements, and option is some values or none, and map is mapping from keys to values, and set of elements is set. So I will explain one by one with example. So you can define. So this is parametric type. So this list type has another type, key. So you can define list of integer like that, list integer, and you can create a list object using list constructor, passing several arguments, so 1 to 3. Then this list 1 to 3 generates an object, list object with 1 to 3. So it is this list same with this 1, 2, 3 deal. So actually deal is special notation for empty list. So deal has it means empty list, and you can append any integer value using the colon notation. So this is append, insert. So you can insert this 3 into this list, 2 into this list, 1 into this list. But it is not mutable data structure, it is immutable data. So if you insert this 2 into this list will not be changed. So just adding this 2 and to create another list object. So they are totally different objects. And also you can pattern matching on list like that. This means this is if it is empty list, return 0, and so this LST has this list, and if in this case H is 1 and T is 2, 3 nil. So it returns H means 1 in here. So it returns 1. So this is a list collection, and also it supports several helper functions: reverse, filter, map, and fold left. If the reverse function just creates another list object with reversed order. So if you call LST reverse, LST it will not be changed. It creates another list object, and this order is just reversed. And also filter creates another list object with this filter. So again, this is placeholder. So this is function value, takes first parameter and passes into here. So it means predicate function for checking the input value is odd or not. So with this predicate, we can filtering, then it creates another list 1, 3. And also you can passing another function into using map helper function. Then this is double function. So it maps the function into each element. Then original LST is 1 to 3. So apply this function into each element, then it becomes 2, 4, 6. So LST.map double function creates another list object like that.
So it's possible to net operator?
Yeah. And also fold left is much more complicated helper function. This first argument is initial value, and this is the function. So it has 2 placeholder. So this is equal to get x 2 parameter and return 2 parameters. So this syntax, same with this syntax. So it passes addition function, and ls default left 0. 0 is can you see this? Okay. So 0 is initial value. So first 0 is initial, then plus is adding two integers, and LST is 1, 2, 3. So first applying these two integer to this plus, then it returns 1. Then apply these two integer here, then it returns 3. 3 and 3 plus equal 6. So for the left applies this mechanism into that initial value and function. So this is for the left. I think this for the left is really helpful to implement your homework. So I recommend you to use this function in your homework later. So his question, is this index? No, it is not index. It is initial value. Yeah, you're right. So this is initial value. This is the function value. So apply with lists and initial value. Apply pairwise. Yeah.
Why don't we use the map?
Why we use
Why can't we use
map in this case?
No, circle line. Circle line.
Sort line here. Here.
No, circle.
Sort line here.
Yeah. Above, like LST match. Why can't we use the phrase?
You mean this path matching?
Yeah.
Yeah, in this path matching it returns just in here.
Why can't we write map instead of match?
But map returns just list. So what is your question? I
So
can,
this refers only to input.
yeah. Yeah. Oh. Yeah. So reverse field and map returns always list of integer if the LST is integer, list of integer.
One more thing. Could you please explain the fold function?
Fold again. Yeah, so yeah, I think I can use here. Can you see this? Okay. So this is another example. So this is initial. In this case, the initial value is 1, and this function is multiply function. So we at the first time with initial value 1, with first element 1, just apply this 1 and 1 into this x and y. Then it returns just 1, right? Then keep that result 1, and then that result 1 insert into here, and 2 is passed into here. Then 1 multiply 2 is 2, right? Then 2 again came here, and 3 will be here. Then 2 multiply 3 is 6, 6 will be here, 4 is here, 6 multiply 4 is 24, x will be 24, and 5 will be here, and 24 multiply 5 is 120. So in this mechanism, both left. Okay. Okay. So next collection is option. Option also has parametric type. So in this case, this is option of integer. Option of integer has two cases, sum or none. So option of integer type has sum or none, and sum has some value, and none has another not value. So you can assume that sum is case class and none is case object. So this none has nothing information, but sum has some information with this given type integer. So it has some integer value. So you can apply math function like that. So it means that if it has some value, apply this function. Or it is none, just give none. So this is math function for option type. And also get OS. So this is default value. If we have some value, returns it at that value, or else this value. So if y is none, so y return 42. And float is also its initial. So it is default value, and this is function. So it is combined version of getOS and map. So if it has the value 1, then just apply this function. If it is none, we use 42, and 42 will be assigned to this function. So this is how to use map, getOS, or fold function in option type. I will introduce option type because of map type, because map uses option type. So map is the some map from key type to value type. So this is kind of map. So you can define a map like that, map object like that. This is key, 0 points to 42 and 1 points to 17. So you can add more points. So you can add 1 points to 4, 1 points to 4 into this map. Then this plus addition function creates another map. So m will not be changed. M is always this map. And m plus 1 to 4 will create another map object like that. So actually, 1 is already points to 17, so it changes to value 1 points to 4. And 7 is not defined in M, so it creates another map, another point, 7 to 0 in here. And you can remove some key like that, and also n minus 0 is removed version of m with removed 0 t0, but also again m will not be changed. M is always here. So and you can get some value of key. So if you want to value of key 0, then use the get function. Then in map m 0 points to 42, so it returns some 42 option type in here. But if it does not have key 7, so it does not return anything, so it returns none. So get function type have integer to option type. So get function get integer type integer and returns option of integer. And getter else is similar with this getter else. If the key 0 exists, then returns the value, or the key 2 does not exist, then returns -1. So this is the default value. So this is about map. Set is just a set. So the set.
When you're defining cloud, is it included in that object?
Sorry.
Okay. So it doesn't change the map itself. For example, n plus 7.
It does not change.
It does not change the n itself, right?
So be careful. There is immutable variable and immutable collection. It is different. So there are 4 cases. Immutable variable val. So from now I will change the name of mutable map into M map. So there are 2 times 2 cases. So there are mutable variable, immutable variable with immutable collection, and immutable variable with mutable collection, and mutable variable with immutable collection, and mutable collection with mutable collection. There's 4 cases. So if it is variable is immutable, then you can reassign the variable. This is a mutable variable. This is a mutability of variable. And there is mutability of collection. So even though the variable x m is immutable, if it is mutable data structure, even though the variable n is immutable, but the collection n map is mutable map, so it has the operator plus equal operator. So m has plus equal operator, so you can modify the variable collection m. So after applying this command, so the m changes into this. So M has 1.2 like that. So be careful, there are differences between immutability of variable and immutability of collections. Okay, so this is math. Set is just a set, so it does not allow same elements. So if you add S1 into 1 into S1, then 1 does not exist, so it appends into set, but 2 is already in S1, so it does not add it into S1 because this set is not list or like the kind of sequence. So and also you can remove some elements like that, and you can check the contains whether S1 contains 2 or not, like that, or you can append a union of 2 sets like that, and also you can calculate intersection between 2 sets S1 and S2 like that. So I introduced 4 different collection libraries. It's already defined in Scala. Okay. So I will explain homework in this course. You can download Scala in this website, and we will use SPT. SPT is the simple builder tool Scala. So you should download SPT. And also, if you want to use IntelliJ, the Java IDE, you can use it, but we recommend you to use just terminal. Yeah. Even though you write the code or see the syntax or see the information in IntelliJ, we will recommend you to run the project on terminal using SPT. And this is structure of our homework project. So this is top directory, and it has IDEA. It is related to IntelliJ configuration. So if you want to use IntelliJ, then use this configuration file, and these 2 files related to SPT project setting. So you don't care about these 2 files. And this is real homework directory. So in this source directory, there are a homework 1 directory in the homework1.zip. Then there are 3 files. Homework 01.scala shows the spec of the homework, and homework hw01.pdf explains what you should do, and package.scala is complete. You should change this file, only this file, complete missing part in this file. So this is a homework. You should change this file, only this file, not other files. And also, after this time, the homework will be uploaded as directory named hw blah blah. Then you just push it into this directory, CS320, parallel with hw01, like that. Then you can compile and test, and also you can run the your project using SPT console command. And there is tip, just type SPT, then it shows the another interactive shell. Then just type console, and then it shows same way. And then if you when you change the code, just exit this column, then that remains the SPT shell. Then just again type console, because the time of SPT is initialization of SPT is quite long, so I will recommend you to that way. So I'm sorry, so this is not my document, so I cannot see that. So this is how to compile and test your code and import your homework directory. So in this case, it's homework 1. So you type HW01 here, and then we provide several helper functions. Test exec. Test is the test equality between two arguments. So if they are equal, then it does not show anything. But if they have different values, then it shows the error message, the file name, and the code line, and the value of two parameters. And also test exec is about test about exceptions. This test about exceptions. So in these cases, if you want to pass this test exec, the first argument should throw an error, and the error has the message contains this string. So in this case, the error function that we provide you in this code for error ABCD, then the error message contains ABCD. So ABCD contains A, so it passes, but ABC does not contain E, so it does not passes. And also we will provide multiple testing by using the function named test. So if you in the source code there is the function named test. So put your own test cases in that function, then just test in the Scala console. Then you can test all the tests you inserted in the source code. And also there is another option, alt only fail. So if the default is alt only fails true. So in that case, when it passes, it does not show anything. But if you turn off this option, then even though it passes, it shows the message with pass message. So, and for submission, you can submit your homework in this homework site, and upload only package.scala, not entire project. Just upload your package.scala in the homework directory. And again, do not use mutable variable or loops. If you use mutable variables or loops, imperative style loops, then you might lose some points in the homework. Might be. I don't know, but yeah. So, do you have any questions?